I have one final note about looking at the result files that your FEA simulation will generate. And I've mentioned that, mentioned in the other video that these result charts sometimes are a little confusing to look at, especially when you're just learning the subject, and that's totally normal. So one thing that I like to do to make this a little bit easier to look at is to change around the definitions of this chart. So if I right click on my particular result area and go edit definition, like where we talked about, you can change the deformation scale. I can also change the units and the display of what this means. So right now I'm looking at the stress chart. And the stress chart for this particular simulation is showing the color chart for what the stress level is in this part. And this red arrow here in the middle is the yield strength of this particular material. And what that means is that any stress level above this arrow, the material is actually yielding or starting to fail or tear or crack or whatever the failure mechanism of your particular material is. Areas with stress greater than where that arrow is are breaking, essentially. So we've shown that with this load and this restraint on this particular part with this particular material, we expect that the part would break, is what the red arrow means. So I can change my deformation scale there. I can change the units. So I'm going to change my units to PSI rather than newtons per square meter. And then if you go to chart options, you have other things that you can select how it displays this chart. So I like to look at it as floating point numbers rather than in scientific notation. So you can see when I regenerate this, now my chart is showing in PSI and displaying the numbers. So a lot of times if you are looking up imperial material values, the yield strength will be listed in PSI. In metric, it'll be listed in newtons per square meter or pascals. So it'll be listed usually in mega or gigapascals of what the failure would be there. So you can manipulate your units to make it a little more obvious how much this is moving. Same with the results for the displacement. I'm not digging how it's showing it in scientific notation in millimeters. So I'm going to go to chart options and do the same thing. And so now I see that my peak displacement is somewhere around 1.8 millimeters. That makes a lot more sense. The last thing I wanted to show you is your analysis tools for looking at areas of this part. And the one really convenient one that you'll use a lot is the probe to just find out what is the particular stress or strain or displacement at some area of interest. So if I go to the simulation tab at the top and then go to result tools, kind of in the middle, and then find this one called probe, then it will let me click on different areas that it'll show me the particular values of interest I'm looking at. So I'm going to pick a couple here to take a look at. So this node around the bolt hole has a peak stress of about 98,000 psi. And then the node over here close to where this corner of very high stress is, same thing, is up around 100,000. If I get right on the red spot, that's where it's at 270,000. So there's other tools in there that you can look at and play with. This is a really handy one just to look at one particular area of interest rather than trying to figure out where in the shade of the color chart the stress level actually lies.